Hello geometry students. We're going to do the examples from our congruent triangle and CPCTC um, review. So right here on number 1 we're going to talk about these congruent triangles and acknowledging the congruent parts. The easiest way to do that, of course, is to look at the tick marks and the arc marks, as we affectionately call them. And the easiest thing is to start with the angles. So right here, angle H has 2 arc marks, and the other angle that also has 2 would be angle I. So we are going to start off by saying that angle H is congruent to angle I. G has a right angle in it, which E also does, so G is congruent to E. And finally, EFI. Now, EFI, the F is in the middle, so that means F is the vertex, which has 1 arc mark. So the other one that has the 1 arc mark still is at F, and that should be GFH. So now to get our congruent triangle, we just have to focus on what are the corresponding pieces. So F, well, the 1 arc mark was also there for the other triangle, so F corresponds to F, G corresponds to E, and H corresponds to I. So now if we look at FG, that has the double tick, so the double tick on the other side is FE. GH has the single tick mark, which would correspond with EI. And finally, FH has the triple tick marks, so FH corresponds and is congruent to FI. And don't forget your symbols. Now we're going to go down to 12. 12, we are given that they are congruent. We just have to go through and determine how exactly are they congruent. So by looking at the picture, we notice that they went ahead and labeled these sides as being congruent. We also have these angles being congruent. And it doesn't look like enough is marked, but if we notice right here in the middle that reflexive property, which allows us to have that shared side being congruent, so that is also a side. So thinking back to our congruencies, 2 sides and an angle, that would be side, angle, side, but that would imply that the angles between the 2 sides. That angle, our right angle, is not between those 2 sides, so it's not side, angle, side. So now we have to think, what is another option? And if I look, I see a right angle, that makes me think, oh, well, this is a right triangle. And another option to being a right triangle means that these sides right here across from it would also be a hypotenuse. And looking at that shared side, that would have to be a leg. So since this is a right triangle, we have our special case that this is proven by hypotenuse leg. Alright, so now on to the real fun. We're going to do a couple proofs. So first things first, in our first proof on number 17, I noticed that we finish up with the fact that our triangles are what we're trying to prove. And Since we know that we're trying to prove triangles, we know our last step is going to end in side, 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 angle, or angle, angle, side. So we know that that's where we're going to stop. And then when I look at my givens, I have 3, but there's something special about these last 2 givens. These last 2 givens, I notice that there's a congruent in between both of them, which sets them both up to be milestones. So I'm going to start with them instead of starting with this perpendicular given first. So JM congruent to LM, that is given. And that particular milestone is a side. So our next one, we're going to look at that third given, angle JMK, is congruent to angle LMK. And that, of course, was also given. And as mentioned earlier, that is a milestone. And this particular milestone is that we proved congruent angles. Now, this one isn't marked on the picture, so let's go ahead and do that. JMK is that angle right there, and then LMK is the one right below it. Alright, so going back, number 3, we're going to pull out this perpendicular KM and JL. And I'm going to fix this M really quick. So KM perpendicular to JL. So what that requires me to do is think about, well, what does perpendicular mean? And after many, many times of talking about perpendicular, we know that perpendicular intersects to form a right angle, which just so happens to be exactly what they marked inside of the picture. So since I know perpendicular means intersects to form a right angle, I can now say that angle JKM and angle LKM are right angles. And that is the definition of what? Well, perpendicular. So if we see a symbol or a vocabulary word, big concept word, typically we use it in the very next reason. So now 5, because I still haven't hit a milestone, so I've got to use this right angles thing. So right angles, I know all right angles are 90 degrees. So if they all are 90 degrees and all have the same measure, that means they should be congruent. And that is a definition. Well, it's not definition of right angle. Shame on me. Should not write that. Instead, we should just write that right angles are congruent. So we hit a milestone there. Our milestone is that we proved angles are congruent. So we have 3 milestones. That should imply that we probably can do that prove now. And how are those congruent? Well, we had an angle with a right angle, we had an angle on the other side, and then we had the side that was not included. So that would be angle, angle, side. Alright, so now on to our last proof. Notice that we have the prove is trying to prove a pair of sides. Well, what that implies is we're going to do some CPCTC. Corresponding parts of congruent triangles are congruent. And before we can prove CPCTC, we have to do like the last problem, prove congruent triangles, and we're going through the whole process of milestones again. So here, notice the given. It looks like one statement, but that word and is a bit tricky, and it really means that we have 2 givens. So our first given statement, M is the midpoint of our segment PQ. That is given. Now midpoint literally means the middle point. So if it's in the middle, it splits our line segment in half into 2. So since PQ was being split into 2, that means that PM should be congruent to MQ. And that is definition of midpoint. Alright, so step 3, and let's notice we did hit a milestone with that. We proved sides. So step 3, we're going to go with our second given statement. It is that M is the midpoint of RS. Which of course was given. Number 4. Since RS is being split in half by the midpoint, we should have RM congruent to MS. That is the definition of midpoint. And that again is our side. Alright, so now that we've used all of our givens, we need to look at the picture and one of 2 things. Either shared side, which is the reflexive property, I don't see that, or we have vertical angles, which there is a cross or an X pattern that's going on there. So we know we're going to have vertical angles. And those vertical angles are angle PMS is congruent to angle QMR which is our third milestone. And if we look at that, the angle is between those two sides. So that should be that our triangles are congruent by side angle side. So triangle PMS congruent to triangle QMR. And finally, since we just proved that triangles are congruent, we get to write our proof statement. So QR congruent to PS, and that is CPCTC. All right. Good luck, guys, on your test, and you'll hear me at your next video.